All right, good morning, everyone, and welcome to today's episode of Pulumi TV. My name is Luke Hoban, CTO at Pulumi, and today I'm going to be talking about Pulumi 0.15. So we just today released the most recent update to the Pulumi tools, and that's version 0.15. So it's hard to believe it's just been about a month and a half since we publicly launched Pulumi. We've gotten great feedback, a lot of folks jumping on and using Pulumi over the last month and a half. And really, this is the first kind of big release we've done since the initial public launch. And it has a lot of features which are both things we've been working on beforehand with folks in the Pulumi beta, but also tons and tons of things that we've worked with folks in the Pulumi community to build out over the last month or so, including many great contributions from folks who have been contributing to the open source project. And so today I'm going to use the next 30 minutes or so to talk about kind of some of the things that are new in Pulumi 0.15. So for folks who haven't joined us before, Pulumi is a new approach to a cloud-native development platform. So a new way to take cloud-native applications that are built to sit on top of the major cloud providers, and that take advantage of the resources and capabilities of those providers, and make it really easy to deploy, manage, and code up applications on top of these. And so I'll show some examples today of kind of some of the new things we've added. But for folks who haven't looked at Pulumi before, I also encourage you to go check out some of the previous videos or check out pulumi.com to get more details on Pulumi. So Pulumi 0.15 has new features across the sort of whole breadth of the Pulumi user experience. So everything from the core kind of authoring code experience. Pulumi is now faster, is a bit simpler in some key ways, and has richer support for some of the existing platforms that Pulumi targets, like AWS and Azure and GCP. But we also now support some new platforms, like Kubernetes. We've significantly enhanced the support that Pulumi has for Kubernetes. We've also added in OpenStack support as well. So you can target not just the major public cloud providers, but also some on-premise solutions and Kubernetes, which can sit on top of both. We've also sort of extended Pulumi's support for integration into the sort of application lifecycle, into the CI/CD flow, to also include a GitHub application. Many of our users of Pulumi have their source code on GitHub, and so the GitHub application for Pulumi makes it easy for those users to actually integrate Pulumi into their CI flow and get the feedback about what the previews and updates that they're doing are going to do to their infrastructure. So I'll dive into all of these areas a bit more in detail over the next 30 minutes, and we're going to have follow-up posts as well over the next probably week or so to go deeper into several of these topics. There's a lot of interesting content in each of these areas, and so we'll have some more content to talk about there very soon. So the first and probably the biggest new capability is really the Kubernetes support. And we actually had, at launch, we did have some initial Kubernetes support, so you could use Pulumi with Kubernetes. But we've really enhanced that in almost every way as part of this 0.15 release. And that sort of starts with the raw ability to use Pulumi with Kubernetes. We built our own provider for talking to a Kubernetes cluster. That's this @Pulumi Kubernetes package. And that package, one of the really important things about it is it gives you access to 100% of the capabilities of the underlying Kubernetes API. So you can use every feature of the Kubernetes API on the cluster that you're targeting. And we'll expose all of those into the Pulumi programming model so that you can work with them and deploy applications against them. We've also added really rich status updates. So the ability to actually see the progress that's happening when you're deploying some of these more complex Kubernetes objects, like when you're deploying a Kubernetes deployment or a service, which themselves have lots of internal pieces that they're managing. It turns out there's many things that can go wrong in that process, and understanding and having visibility into what's happening as those progress is really important to be able to reliably and repeatably deploy your Kubernetes applications. And so with the Pulumi provider for Kubernetes, you can now get insight into those things as you deploy the application. Another key thing we've done working with a bunch of customers and users over the last month or so, we've heard that almost everyone using Kubernetes today is relying on Helm charts, both ones they develop themselves and as a repository for existing applications and existing components from third parties that they want to bring into their Kubernetes cluster. And so we've added first-class support for Helm charts as well, so that you can describe not just Kubernetes objects directly in Pulumi. You can also point at a Helm chart and say, I want to import all of the content from that Helm chart and deploy that using Pulumi. And so this means there's a much easier way to work with existing assets and bring them in and manage them and deploy them using all the features that Pulumi brings. The last thing, and the thing that I think is sort of really sort of interesting to think about from a Pulumi perspective, is that because Pulumi lets you manage existing cloud resources in AWS or Azure or GCP, you can manage both the cluster, for example, EKS or AKS or GKE in the cloud provider using Pulumi, and you can also manage the Kubernetes resources that are deployed into that. And this has been a pattern that, as we've talked to folks, we've seen many people trying to manage sort of a combination of a Kubernetes cluster and some core Kubernetes objects that need to live inside that cluster before it's really a fully configured and usable environment for them. And so this combination of being able to deploy both of those and manage them and version them in a single Pulumi program is something that we think is a really nice and fairly unique capability that Pulumi can bring. And this experience, of course, extends not just to managing the cluster, but also potentially other cloud resources. So, for example, managing some S3 buckets or a hosted database inside a cloud provider, and being able to access them and use them from within your Kubernetes cluster, but being able to version both the Kubernetes resources and the cloud resources in the same file. I'll go and show an example of this in a little bit more detail in just a second, but I want to talk about a couple of other features that we've added that I'll highlight as part of that example before I dive into that. So the first, and these are things that are very useful generally, but also are particularly valuable for Kubernetes scenarios as well. So the first is parallelism. So when we launched Pulumi, we did not yet have parallelism in our deployments. And so that meant that we would infer the graph of dependencies from the application and then deploy those in the order that was required to successfully match the dependencies that existed in a user's program. However, when we did that, we did it sequentially, so we didn't take advantage of the places where there were maybe many resources which were mutually independent but could be deployed concurrently. This made deployments slightly slower than they had to be in some cases, and so with Pulumi 0.15, we've added in support for parallelism. And that means that in general, every deployment you do with Pulumi is going to run faster. For some deployments, that's a lot faster. We default to up to 10 wide parallelism, and so you could see your deployments go as fast as 10 times as quickly as they did previously. But in general, even for small and targeted updates, you'll see some amount of benefit here because there's very frequently some amount of independent work being done. And so we'll typically see 50% to 2x improvements on almost every deployment that you do. So this makes it just much faster. The inner loop for developing with Pulumi can be even faster than it was previously, and generally is a benefit for every user of Pulumi. It's particularly important for Kubernetes, where many of the dependencies are not explicit between Kubernetes resources, and Kubernetes is designed to be able to just throw a bunch of different resources at the API server, and it'll figure out how to make them stand up as fast as they can. And so because of that, parallelism is particularly important because the actual dependency management is all being done inside Kubernetes instead of inside Pulumi. So that's a great feature. I'm super happy that that's available now for all Pulumi users. Another really important piece that we added is something we call first-class providers. And so in Pulumi, we have this notion of providers, which is like the AWS provider or the Kubernetes provider or the OpenStack provider. And these are components that are able to talk to a particular cloud platform or talk to a particular hosted environment and deploy resources managed by Pulumi into that environment. And prior to 0.15, you could use there was sort of always one ambient provider for every one of these different platforms. So if you imported the Pulumi AWS provider, you could talk to and deploy resources to AWS, and you could configure that provider using whatever configuration you wanted, the account credentials, the region, other details like that you wanted to set. But there's many scenarios where you want to sort of have multiple providers. So for example, if you want to do multiple regions and manage resources in multiple regions from the same Pulumi program, you need multiple instances of the AWS provider, each targeting one of these different regions. And so with first-class providers, we can instantiate new copies of the provider with different configuration that's provided within the Pulumi program instead of externally via Pulumi configuration. And this opens up a whole bunch of new scenarios where you can mix and match deploying to multiple regions, or even deploying some infrastructure on one cloud provider, and then using outputs from that infrastructure to initialize a provider for some other capability. So for example, when we deploy a GKE cluster in Google Cloud, we might want to then go and deploy Kubernetes objects into that cluster. And to do that, we need to initialize the Kubernetes provider with outputs from that GKE cluster that describe the credentials for how to access it. And so these are the kinds of things now that we can do in a single program using Pulumi because of first-class providers. Another one that's we've seen is a lot of the users of Pulumi. Pulumi currently supports JavaScript and TypeScript and Python and Go. We've definitely seen a lot of users choosing to use TypeScript so far, in part because that's where a lot of our libraries have been designed, but also because TypeScript gives users a lot of the nice error checking and tools benefits that are really nice to have in deploying and managing infrastructure. And so with this release, we've actually gone and taken our TypeScript support one step further and baked it natively into kind of the Pulumi deployment engine. And so previously, you could use TypeScript and you could compile it and compile it down to JavaScript and run that in Pulumi. But now you can actually take .ts files and use them directly inside your Pulumi programs. And this just makes it much simpler to get sort of the benefits of TypeScript without having to burden your workflow at all around the compilation process and that sort of thing. And so we expect this is going to, again, make that inner loop just much simpler and make it much more attractive for those who want to use TypeScript with Pulumi. So that's the first sort of batch of features that we've added. Let me show a demo to kind of highlight all of these kind of working together. So I'll jump over here into Visual Studio Code, and we'll look at a simple Pulumi application here. And so this is kind of highlighting that scenario that I touched on a couple of times there, where I want to both stand up a Kubernetes cluster in a cloud provider. In this case, I'll work with Azure and with the Azure Kubernetes service. And then I want to go and deploy some Kubernetes resources into that cluster. And so let me walk through and kind of show you some of what I'm doing in this particular program. So first off, I'm importing from a few different places. I'm importing the Pulumi Azure package, the core Pulumi package, which just has some helpers that we can use with Pulumi generally, and the Pulumi Kubernetes package. I'm then going ahead and accepting some configuration. So to run this example, I need an SSH key that I want to use to be able to SSH into the VMs that are backing the Kubernetes cluster. And then I need a client ID and a client secret to provide to the Azure Kubernetes service so that it can go and manage resources in Azure on my behalf via the Kubernetes API. So things like allocating load balancers or allocating storage inside Azure for me. And so I'll declare that stuff as Pulumi configuration, which means I can come in down here and say Pulumi config, and I can set these using Pulumi configuration. And we can see, for example, that this client secret I marked as a Pulumi secret, and so I don't echo it here. But the other ones are not secret, so I have them just available here so that I can see and make sure I'm working with the right values. But this is easy to now do through the configuration system in Pulumi. I then create a resource group in the West US region of Azure. Then this is the resource group where all the resources are going to be allocated for this program. And then I go ahead and just create a Kubernetes cluster. And I'll just show this all on one screen. It's a little bit of configuration here that I need to create this, but really actually surprising little. The Kubernetes cluster API for AKS is very nicely designed and exposes a lot of nice options, but with good defaults for many of them. And in this case, I'm just going to create a fairly small Azure Kubernetes cluster. I'm going to provide that SSH key and those client ID and client secret. So I've run this program with just those components deployed, and what I can do is I can say Pulumi stack, and I can come over here and do a couple of things. So one, I can come and look at this deployed cluster inside the Pulumi service, and so I can get all of the details of this stack, so those same configuration that we saw earlier, but also some of the outputs of this. So we see that I have a resource group and a cluster that I created. We see also that I have a browse command, and so in this code, if I come over here, you notice I have a few exports. So I exported that resource group and that cluster. I also just exported a helpful browse command, and this uses the Azure Cli and exposes those the outputs of this. If I come over here and just run that, oh, sorry, I need to grab the actual one from here. Okay, so that will actually run. Oh, did I already have this running somewhere? Okay, I already had this running. Let me try that again. This will actually use the Azure CLI to launch a proxy that lets me see what's running inside this cluster in the Kubernetes dashboard hosted inside that cluster. And so we see it actually creates a proxy tunnel to that using the standard kubectl proxy mechanism. So now I can see what's actually running inside my environment here. And if I come over here, we can see just sort of some of the standard things. So, you know, I've got the two nodes that I asked for that are running inside Azure. I've got, if I come down here, I've got the core Kubernetes service, the API server running inside my cluster, but I don't have anything else. I don't have any deployments or any other custom services inside this cluster so far. So let's see what it's like to actually deploy something into this. So in this example, I can take that Kubernetes provider that we talked about, this first-class provider, and I can create a new instance of it. So I can say new k8s.provider. And this allows me to create a new instance of the Kubernetes provider that's initialized with configuration that I get from somewhere else. And in this case, I'm going to get the kube config from the outputs of that Kubernetes cluster. And so if I go to definition on this, we see that this is the raw Kubernetes config to be used with kubectl or other tools. So this makes it really easy. I can take what I got as the output from this Kubernetes cluster resource and pass it directly into a Kubernetes provider so that now I can deploy any resource I want within that Kubernetes, with the Kubernetes provider. This is exactly, I could do this in exactly the same way with GKE or EKS or any of the other managed Kubernetes services using the equivalent packages for the Google Cloud and for AWS. But for this example, I then want to go and use that, that new provider, this AZK8S, to deploy a Helm chart. And so in this example, I'm going to take the stable Kibana chart, and I'm going to take 0.8.0 version of that. And I'm going to pass in some configuration for it. And so Helm charts all have the ability to pass values in that override defaults. And so this guy's going to override the service type, which is by default cluster IP, to be load balancer, so that I can take advantage of getting a publicly exposed load balancer for this Kibana instance. And I'm going to ask to provision that inside this provider that's going to be running inside my Azure Kubernetes service. And so let me save that. Now, one thing you'll notice, I'm working in TypeScript here, which is what gives me some of this nice IntelliSense and gives me this kind of error, you know, some of this error checking, like I misspelled the name chart. And so I'm working in TypeScript, and so previously I would have had to make sure I was compiling or running some watch job or something. But now we've actually changed to use that first-class support for TypeScript. And so here we see that my main just points at index.ts instead of compiling and pointing at some index.js that's compiled. So we can just point directly at an index.ts file. And if I come over here and run Pulumi update after uncommenting that stuff, we will see that this will preview what changes are going to be made. And so in this case, because I added this Helm chart, we'll see that the preview says I'm going to create three things. I'm going to create this Helm chart, and that Helm chart is made up of a Kibana service and a Kibana deployment. And so those are the two pieces that Helm chart defines. And now we're going to actually deploy those from that Helm chart using Pulumi. And we'll get a sense of kind of what happens while we do that deployment. So I'll go ahead and run this. We'll see a couple of things here. One, all of these are proceeding in parallel. And so this is what we talked about earlier. Because we have parallelism now, we can run both that service and deployment in parallel. If we were creating many, many more resources in Kubernetes, we would try to deploy them all in parallel, assuming there was no explicit dependencies between them. And in this case, the deployment completed fairly quickly. It just had to pull down that Docker image and deploy it into the cluster. The service takes a little bit longer because that needs to both allocate an endpoint inside the cluster, but then also needs to, inside Azure, allocate a load balancer to make it publicly accessible. And that process of provisioning the Azure load balancer can take some amount of time. So while this is going, let's pop back over to the dashboard here, and we'll actually see that we can get insights into these things running. So that Kibana deployment we can see now here inside of the Kubernetes dashboard. And if I come over here and look at the services, we see that the Kibana service is still in progress, and I can see the status events of what's going on. But since we don't want to tell everyone to always be jumping over into kube dashboard or running kube control or running queries to try and figure out what's going on during the deployment, you notice we're also providing more context on what's going on. So while this is creating, we're giving progress as we make, as the service progresses towards being fully initialized. And so in this case, the Kibana service was successfully created the endpoints. And so if we come over here, we see these internal endpoints were allocated. But now we're waiting on allocating the load balancer. And so that'll take a little bit of time to complete. The one other thing I'll show is when we're inside the dashboard over here, maybe it's not done yet. Okay. When we're inside the dashboard over inside Pulumi, Pulumi tracks the status of all of the different updates that have happened. And so here we can see all of the updates I've done to this stack as I've changed it around. And this is the deployment that's currently in progress. I mean, you can see all of the details of what's going on as this thing is being created. So we can keep track of also the status of the deployment from within the Pulumi console here. We can also see all of the resources that are being managed by this stack. And we can even see a nice graph here where we can see that we have this Pulumi example AKS stack. It has a resource group and a Kubernetes cluster that are in Azure, so they're this orange color. And then it has the Kubernetes resources for the Kibana chart and the deployment that are in green. And soon we'll have a service as well. So we can get a sense of all the different resources being managed by this stack, all from within this console. Okay, so this should take only a couple of minutes. Azure sometimes takes more or less time to deploy the load balancer. But we'll give it a couple of seconds just to finish. Okay, there we go. Just finished. So now we should be running that Kibana cluster inside Kubernetes. So if I refresh this, we should have an externally visible endpoint. And sometimes on the first hit, this takes a second to load up. So I'll give it time to load. But this should, once this loads for the first time, we should see a Kibana dashboard running inside our Kubernetes cluster on top of Azure. There we go. So we're loading up a Kubernetes dashboard, a Kibana dashboard. So great. So we were able to deploy a Helm chart onto an AKS cluster, all within a single Pulumi program. So, okay, so that's a really nice quick tour of some of those capabilities. Let me jump back over in the blog post and highlight just a few of the remaining things that we did in this release, most of which are supporting existing use cases. And these, again, we'll have more details on some of these use cases in follow-up blog posts and videos here. So one thing we heard a lot of feedback on, a bunch of the examples that we have for Pulumi and a bunch of the use cases that are really exciting, I think, for Pulumi, are places where we stand up, where we use JavaScript functions as callbacks which get used at runtime. And so in this case, we have a little example where we create a cloud.api, which is going to be sort of an API gateway in AWS. And then we host a route on the root, which is just going to run this simple command. It's going to get pulumi.io and return the status text for it. So this is, this little program here actually stands up, a bunch of resources in AWS to create a managed API gateway, some lambdas, a bunch of other things to make sure that I have a hosted public endpoint for this particular API. One of the nice things is I can just write this code right in line. There's lots of places where I have just these very simple Lambda functions, which I don't want to go and manage a whole separate project and figure out how to upload that into an S3 bucket and wire them together. Instead, I can just write this code inline like this. And so I've seen a bunch of people take advantage of this across a bunch of different platforms. However, people frequently wanted to write code that looked like this. They wanted to import some library in their Pulumi program and then use it from within their callback here. And previously, this was an error, and we actually did not allow folks to do this because this meant that you were capturing this whole package, and we would have to serialize that and make that available inside the runtime environment of the Lambda function. With Pulumi 0.15, we've now enabled this, and we actually make it work sort of in the way that users just expect, that this becomes a require at runtime, just like this does. And that library will get loaded at runtime and packaged up into the deployment package.json. Everything will just work kind of as you expect. And so this makes it so the simple code you want to write to enable these kind of scenarios just works, and you can use these sort of cloud callbacks in a really natural way. We've also extended that support for kind of using JavaScript functions as as handlers for AWS Lambda, and we've also enabled it in a really nice way for both Azure functions and Google Cloud functions. And so in these examples, you see we've done that for Azure, and here we've actually hooked up some nice blob events. So using Azure Blob Storage as an event source. You can just say serverless.storage.onBlob event and then pass one. Go and hit endpoints that you have running in Kubernetes or in VMs. But it's a way to just inject these little event handlers into your infrastructure in really convenient ways. And so we now have an Azure serverless package, which gives you a bunch of these kind of abilities to use serverless events and event sources inside Azure in this really, really simple way, but with the full capabilities of the underlying Azure platform. Similarly, we've gone and added a new gcp.serverless.function, which again is our sort of wrapper around creating a bucket object or a storage object and a Google Cloud function, and wrapping that all up so that you can write just the simple callback and use it as a Google Cloud function. And so in particular, because Google Cloud Functions can support HTTP by default, we can just create one of these functions, get the HTTP as trigger URL, and now use this directly as an API. And so just this really simple piece of code here gives me an API exposed directly to the internet that is managed in Google Cloud Functions and can scale up effectively arbitrarily. So again, really simple ways to use these capabilities inside the applications. And this particular feature was one that one of our users and frequent contributors, Mikhail Shilkov, contributed. So I do want to call out his great work on this and several other things over the last couple of months in the Pulumi community. So one other huge thing that we released as part of 0.15 is support for OpenStack. And so OpenStack is obviously an open kind of API for talking to and managing cloud resources that's supported by a variety of different public and private cloud vendors and is usable in a bunch of different sort of private data center environments. And so we now support this, and this opens up the ability to use Pulumi to a whole bunch of additional users who are working with OpenStack deployments. And so the Pulumi OpenStack package supports the breadth of capabilities of the OpenStack API. And we, for example, are using it in our testing mostly with OVH, which is one of the many providers who supports OpenStack. And so within OVH, for example, I can run something as simple as this to stand up a new VM in OVH. And this deploys in just a couple minutes. I think in the last video we did, I actually showed kind of working with this example and in the Pulumi side and in the sort of upstream OpenStack support that this builds on top of. And so really happy to have, certainly not least, and you can just integrate it by running Pulumi update and Pulumi preview commands as part of the deployment step in your CI/CD system. One of the things we extended in this release is we introduced a new Github app, and that Github app will actually, if you install it into your GitHub account, we will now be able to actually have Pulumi push comments into your PRs about the status of those previews and updates. So if one of your PRs is a pull request to merge into your staging branch, and you want to run a Pulumi preview of what that update is going to do to the staging branch, we will then into the staging branch. And so this gives you a really visceral visibility into the impact that proposed changes to your infrastructure are going to have before you merge those, or without having to go in and dig through your CI/CD logs or whatever. And so this we found super useful. We've been using this ourselves for a bunch of our work. Several of the customers we've been working with have been previewing this over the last few weeks. Really excited to get this out there and get more folks to install the app and start taking a look at that to make it really easy and productive to use Pulumi inside their CI/CD systems. So that's a quick tour of the release. Tons of stuff here. We're going to dive in more in a lot of these areas over the coming weeks, and we're just really still getting started. A lot of these are capabilities which enhance what's already there with Pulumi. We've got lots more to come over the next few weeks and months. So really excited to be working with everyone in the Pulumi community to develop all these features and everything else that we've got coming down the pike. I do want to call out all the folks who have contributed to Pulumi in this release. I talked about Fraser and Mikhail's great contributions. We also had some really important contributions in the AWS providers and in a bunch of other places from James Nugent, who's kind of interested in contributing, interested in working in. Or you can come and join us in our Slack channel. And so our Slack channel, we've got a bunch of folks who are working with Pulumi, asking questions, answering questions, and working on contributions. So anyone who wants to jump in and help out or just learn about how to get started, feel free to join us in Slack. Okay, so that's it for me for today. Definitely encourage you to try out the new O15 bits, give us feedback, and let us know what we should be working on next. Thanks again. We'll see you next time. Bye.